Hello friends, look how impressive challenge number 163 is. We have here a figure where they only give us two data and no, we need to find the shaded area. As always, you can solve it in your notebook and leave me your answer in the comments. The first thing we know is that if we draw a line straight down from here all the way down where it stops, draw a circle with it along the square line. So a square is formed, meaning this side will be 1 centimeter and from here to there will also be a centimeter. So for now we're just going to work with the numbers and put the units at the end. So from here to here measures 1 and from here to here also measures 1. So notice from here to up here how much it's going to measure. Well, 3, isn't it? Because everything on this side here measures 4. And if this point from here to here measures 1, then from here to the top must be 3. Fantastic. Now pay attention. This one also counts this distance here. Therefore, from here to here, that is worth 3. Very well. What else do we have around here? We have a distance which we don't know how much it is, that we will call x. Fantastic. Now this distance from here, take a look. See if this is worth x. And from here to here, it's worth 1. So, since all this here is 4, we know because it tells us it's a square of the side 4. So the base of this triangle over here, that is from here to here, they will measure 4. So per minus 1 give us as 3. So we can say this part here is 3 minus 6. Fantastic. Now pay attention. There is another very interesting data here. When we have two lines crossing and tangent to a circle, look, it's the same. Notice from here to here will measure the same as from here to here, because they are lines tangent to the circle. This part also measures x. Let's erase the shaded area so it can be seen better. So look at this part too.
Fantastic.
Now pay attention to what we're going to do. We're going to join from the vertex of the square to the center of the circle. Notice it this way. Let's connect up to here. Done.
Just imagine it's a real line.
Well, it didn't come out very straight, but let's pretend it didn't. So what we have here is a right angle triangle. Given there are 90 degrees here, that's why it's a right triangle. And so we can find the hypotenuse. Since we have both legs, this leg here measures 3. And this side here also measures 3. So look, the hypotenuse from here, we're going to put here will be equal to the square root using Pythagoras, not because it's a right triangle. A squared, that is a squared plus b squared. Wow. So the hypotenuse will be equal to the square root. What about the sides? They both measure 3, so it's 3 squared plus 3 squared. Very well. Then the hypotenuse measures 3 squared is 9 plus 3 squared is 9. So the square root of 18, fantastic. That if we want, we can write it as the cube root of 2, right?
Let's keep going.
Continuing, the hypotenuse is 3 root 2, fantastic. Let's continue. Look here. I'm going to put 3 square root of 2. That's what this hypotenuse of 2 measures. We'll draw another line step by step. Where is this line tangent to the circle? So here 290 degrees will form because it's tangent to the circles. So here we have 90 degrees, that is, we have another right triangle. Notice, it goes like this. So then this red line would be the hypotenuse from this triangle here. And so this here measures 1 because it's the radius of the circle. So this will also measure 1. And since we already have two sides of our right triangle again, we can apply Pythagoras to be able to determine this side here. Let's do it then. At this moment, we're not going to find the hypotenuse because we already have it. what we're going to find is the cathetos. So look, from here, or well, from the previous formula, look at the original formula. Pythagoras theorem is a squared equals a squared plus b squared. Perfect. So one of these two must be the leg. To this leg I will call A, so this leg will be B. Fantastic. So clearing leaves us h squared minus a squared, and this equals b squared. Right, so simply
We need to go replacing. Let's
we
replace
have
it with
then
the
h squared. What is h? Is 3 root square root of 2 then, but let's write it here. 3 times the square root of 2, and this is squared. Less squared meaning one of its sides. This side here, the one we know how much it is worth, no? So it's 1 squared, and that's going to be equal to b squared. Fantastic. Alright, so what do we have here? We have 3 squared, which is 9 times square root squared. The square is cancelled out with the root index, leaving us with 2 less. 1 squared is 1a, and this equals b squared. Very good, we have 18 minus 1, which is 17, and this equals b squared. Clearing from here, we apply the square root on both sides. Remove the 2 with the root index, and here we should apply the absolute value law, but since talking about we only need the positive value. So let's say then we'll choose only the positive value. The square root of 17 we already have. Side B, notice this side here. The square root of 17 is worth it. Very well. And we almost have all the data to solve for x. So, look, this side over here measures the same as this side over there. So it must also measure 4 centimeters. For now, we're just going to write it as 4. And there a right triangle is also formed. Notice this one here is what we needed, the one that was highlighted. So now we can determine this x to be able to calculate the area. How do we do it? We'll apply Pythagoras again. We had said that h squared equals a squared plus b squared. Very good. So these two are the legs. It doesn't matter whether it's this leg or that leg over there. So what's the hypotenuse squared? The hypotenuse squared. We'll be adding this, that is worth square root of 17 measures from here to here, plus x. So the hypotenuse is the square root of 17 plus x. Let's put it here. Plus x times, very well. And this is squared equals s squared. We're going to open a parenthesis and we'll see that this can be this right here. It can be this one or it can be the 4. Whichever we want. So I'm going to say it's this one, I say. 3 minus 6. And this is raised to the square, right? And here it's more, almost like multiplying plus b squared. So if this is the other leg must be b, that is the 4. And this is also squared. Very good, right? And notice we have an equation with a single variable, meaning we can solve for x. Here, we have a squared binomial solved in the following way. The first term squared of square root of 17 squared plus. Moreover, the double product of the first term, that is of the square root of 17, by the second term, that is x, and plus the second term squared, that is x squared. Very well. This equals, here, we also have a perfect square trinomial, but there's a minus. So let's see how the first term squared would be 9. But we'll write it as it is. 3 squared minus twice the product of the first term, then by 3 and by the second term, which is x, and plus the second term squared, that is x squared. Very good. And here we have 4 squared, which is 16. Now we are going to start eliminating roots and operate. Over here I have the square root, and I have to raise it to the square. It cancels out. And I'm left with 17 more. Around here I have 2 times the square root of 17 times x. We can't do anything here. Plus x squared, and this equals 3 squared, which is 9, minus 2 times 3, which is 6x, plus x squared, and plus 16. Very good. Notice, we have 2 equal terms on both sides of the equality with the same sign, and this can be deleted. And this makes a lot of sense, because if I move this x squared here, it's going to end up with minus x squared. And adding up with this, it cancels out. Now what do we have? Let's keep on the left side what has x, and on the right side what doesn't have x. And around here we have 2 times the square root of 17 times x and y. And over here we have this, which also involves x, meaning the left side adds plus 6x, equal to, we have 9 plus 16, that is 25. And finally C17 remains on the other side as minus 17. Very good. Let's write that up here to continue. So we have 2 square root of 70x. Imanaf product deates napas katia siktesis plus 6x equal to 25 minus 17, which gives us a value of 8. From here we extract the common factor x, because in both we have x, right? And so we open a parenthesis. Therefore, dividing this term by x leaves us 2 square root of 17. Up plus dividing this term by x gives me 6, and this is equal to 8. And then all of this stuff here ends up on the other side divided. So we have x equals, xs goes to 8. 2 square root of 17 of 17 plus, let's erase this because we don't need it anymore from here. We are going to solve for x and we don't need this anymore. Let's erase.
Subtitles by the Amargo community.
Very good. And we already have here. Then what x is worth ready. And here, then this would be the x solution. It is worth this here. But we can still perform some processes to simplify the solution. Let's do it this way. Notice x equals the same. 8 are over. And down here, what are we going to do with this crooked line? What are we going to do in the denominator? We take out common factor, the 2. So it remains 2 multiplied by the square root of 17 plus 3. If we have taken out the common factor of 2, if we multiply this by this, it gives us this here. And 2 times 3 gives us the 6 here by here. We simplify 1/2 and the other half 4. Okay, so we have that this equals 4 over the square root of 17 plus 3. And here we can rationalize so that the root stays on top. So we need to multiply and divide by the conjugate of this here. So what's the conjugate? The square root of 17 minus... This is well rationalizing, isn't it? So about how we multiply by this term, we must also multiply by the same term, and we'll see why. So what do we have left in the numerator? Let's see. We have x equals 4 times by the square root of 17 minus 3 over this here. When multiplied this with this conjugate, then we get a difference of squares. And how do you solve the difference of squares? Well, it's the first term, that is to say the square root of 17. That's the first term. Squared minus the square of the second term. Squared. This is the difference of squares. Now see, we have x equals 4 multiplied by the square root of 17 minus 3. And in the denominator we have the root is cancelled with this 2 and I am left with 17. And over here we have 3 squared, which is 9. So we have 4 by the square root of 17 minus 3 over 17 minus 9 is 8. So we can simplify the fourth one and the fourth two. Done. And now we have a well-reduced solution. We have simplified the solution. We can't simplify it further, so we stick with this. Let's erase all this and just keep the solution. I'm going to pass away. Okay, let's jot down the solution for x over here. We have that x equals the square root of 17 minus 3 over 2 over 2. Very well, fantastic. This is x's solution. Let's erase this from here. So pay attention. We already have the x solution, which means that here, and this term is going to go, we still don't know how much each side is worth. We know that this is 4 and that this side is 3 less. All of this here. But let's calculate it right away.
And the
Why
area
also
for-
calculating the sides when we can calculate the area already?
In a
So
way.
the area will be equal base times height divided by 2. Alright, we have the area which is going to be equal to, what's the base? The base is 3 minus x. That is, 3 minus this because this equals x. So 3 minus the square root of 17 minus 3. Alright, here we go. Perfect. And the height times the height. How much does the height measure? The height measures 4. All of this about double. Very well, we can simplify these 2 with this 4. And I am left with 2 above. And now let's multiply this 2 by each term. 2 times 3 gives us 6. So we're going to put it over here. A equals 2 times 3 is 6. Minus 2. For all of this, notice 2 times the square root of 17 minus 3. This over 2. Over 2, note on this 2. Then we simplify this 2 with this 2. And now we're going to find out it was 6 less than the square root of 17 minus 3. Here it's plus 3, sorry, because minus by more gives me less and less. By less gives me more. So we get that the shaded area is going to be 6 plus 3, which is 9. Minus the square root of 17, fantastic. We have already found the solution, square centimeters. This is the solution. It's the shaded area. We've already found it. Amazing. We've gone through so many steps to get to the solution. Amazing, fantastic exercise. Let me know in the comments if you like the video, and don't forget to subscribe and hit the like button so you don't miss the next challenge. Gusto rin para sa na.